Thank you very much for the introduction. It's fascinating listening to all the questions. Slightly daunting because all of the speakers so far have told you that I have the answers to all of those questions. I'll do my best to answer some of them, perhaps, but I can't promise everything. Anyway, so I'm going to be talking, as some of the questions have alluded to already, I'm going to be talking specifically about the issues of food security. So as we know, food security is one of the most profound issues for humanity today. We have a growing population. There will be more mouths to feed in the future than there were in the past. We have growing wealth in many parts of the world, which is associated with changes in consumption patterns of food, which has environmental and other impacts. We have a globalized world. We have teleconnections, interactions between different parts of the world. We have trade wars emerging between, let's say, the US and China, which have implications for the way in which food is supplied, notably in this case, soybeans. So there are lots of profound drivers of change within the food system that we already know exist. Then, of course, climate change is going to exacerbate many of those problems. It's going to be another layer of complexity and difficulty within the food security system. Climate change will impact on crop yields and production, the distribution of cropping, where we grow crops where. It will impact on irrigation, water availability. It will affect pests and diseases, and it will affect extreme events. So the many, many issues we know are going to have an impact on food security. But there's another dimension, and that dimension relates to land-based climate mitigation. We know that climate change will be a problem directly for food security, but we also know increasingly that some of the measures to mitigate climate change could in themselves also have problems for food security. And some of the previous speakers have already started to allude to some of those issues, which I'm going to try and pick up on and primarily start to look at some of the issues around consumption as well as the supply side of land use change. So this was the figure that Almut put up earlier, and it in a way gives the reasoning behind the need for the world to consider land-based mitigation. It is around this notion of net negative global emissions. We have very few technologies with which we can extract carbon from the environment. Planting trees and bioenergy are two of the technologies we have available to us. And this is a quote from Almut. I thought I'd follow on from the previous speaker. So further inaction in the rapid reduction of anthropogenic greenhouse gas emissions raises the prospects of relying on drastic land-based climate change mitigation measures in order to achieve the Paris Climate Agreement. So we have the real prospect that we may be faced with having to deal with land-based mitigation. So what is land-based mitigation? It's a whole basket of options that we have available to us, and we need to reflect on what these are. The first set of options relate to reducing greenhouse gas emissions from the agricultural sector, from the food system itself. We can better manage cropland, grazing, and livestock systems. If we do that, we can reduce emissions from those systems themselves. We can restore different ecosystems. We can better manage peatlands to avoid emissions of carbon from peatlands. We could increase energy efficiency in agriculture. So these are just a few examples of the things we can do to reduce emissions. But of course, that won't actually get us to the point where we start removing carbon and other greenhouse gases from the atmosphere. So we have to look beyond this. And I'm not going to talk about these issues. That could be another talk for somebody else to give on another day. But what we are going to be thinking about here, is, which is the main theme of this symposium, is to think about removals of CO2 from the atmosphere and the consequences of that, which is what I want to focus on, the consequences for the competition for land. And the two primary technologies, as you well know by now, bioenergy and reforestation, afforestation, potentially including agroforestry. And the competition for land is the basic issue that we're having to deal with here. And I want to start by showing you some of the problems to continue from the previous speakers, but I also want to move on to reflecting a little bit on whether we can find some solutions to these problems as well, using the land more efficiently as a resource. So this simple schematic just shows us that actually land is a finite resource. There is only a certain amount of land that we have available to us, and we have many conflicting demands on the uses of that land. Everything from the cities we live in, through the protection of ecosystems, of biodiversity, the production of food, and also increasingly land-based mitigation, bioenergy, etc. So there's this massive competition between these different uses, and we as a global society need to start reflecting on the decisions that we can make to best use those land resources to maximize the benefits that we gain and the benefits that biodiversity gains from the use of those resources. So here's a slightly complex graphic that I'm just going to take you through, which gives you some ideas of the trade-offs that we're faced with. So this was a modeling study that we undertook to try to explore future projections from more or less today to the year 2050, looking at how we could use, alternatively, global cropland. Okay? So it was a global land use change model that we were doing here. It's what's called a normative approach. We were trying to achieve certain targets in the future, certain goals. And those goals were based on a food supply target where we wanted to provide food for the global population, reflected in terms of a minimum amount of calories. It also looked at trying to do that within the cropland planetary boundary, set as 15% of the terrestrial ice-free surface. The idea there is we don't want to expand into the space available for broader ranges of ecosystems and biodiversity. But we also wanted, in this particular analysis, to see if we could increase or meet certain bioenergy targets. In this case, we're using an OECD target, which looked at doubling first-generation energy crops from 2000 to 2050. First-generation energy crops are basically the food crops that we can use also for energy. So maize for bioenergy, for bioethanol production, sugar beet, wheat, and oilseed crops as well. So what the analysis shows, each of these lines, what you won't see, is there are actually 200,000 individual lines marked on this graph. And they represent, each of those lines, a single run with the model we were using in this case. And we use those 200,000 model runs to explore different parameters within the model. We're exploring the parameter space. What can we do in terms of changing the ways that our food system operates to try and achieve those targets? Looking at the supply side of food, but also the demand side, which I'll talk a bit more about later on. So what the blue curves show is where we can achieve the food supply target for 2050 based on the FAO's doubling of food production to meet a growing population growth. And as you can see, actually, there are lots of situations where we can achieve this. By the way, the dotted line shows the current global cropland area. So we can actually, in many of these scenarios, achieve global food security if we just look at feeding the population. If we then look at trying to do that by constraining the area of cropland, that's the yellow curves, then we're starting to have a few more problems here. Right? We can just about, sorry, that's the, beg your pardon, that is the global planetary boundary for cropland as the dotted line. So these yellow ones just about meet that expectation. The last target, though, the bioenergy, we found there was only one out of 200,000 simulations of this model that enabled us to almost meet all three targets. It didn't quite. So what we're seeing from this analysis is we can't actually achieve the three targets that we sought to achieve. It's not feasible to do that. That's under current conditions, current assumptions about the ways in which the food system works. So this is an example of, that's an example of the problem of trying to use bioenergy as a land-based mitigation approach. This is an example of one of the problems of afforestation or reforestation as a mitigation approach. This is a study, again, using a different model than the model I showed you in the previous example, but it's looking at the effect of different stylized scenarios of reforestation, whether you have unrestricted afforestation, whether you have no afforestation in the boreal areas, and whether you only have afforestation in tropical areas. This one shows avoided deforestation, which is always a good thing, as Alma pointed out earlier on. And what you can see, these stylized scenarios, they're not trying to replicate reality. they're thought experiments trying to think about what might actually happen. And what this shows is if you look at the CO2 emissions, actually the two afforestation, or the three afforestation scenarios here, give you major benefits in terms of negative emissions. So you're actually sucking carbon out of the atmosphere because you're growing more trees. Very, very positive. But on the right-hand graph, you'll see this is a food price index. What you'll see is for those same scenarios that give you really massive carbon benefits, you see very, very large increases in the food price index. So food prices, if you look at the present as 100, up to almost 4 times the level of prices than we currently have. And that's simply because of the competition for land. Land is a scarce resource. If we reforest, we have less land for agriculture, for food production. That puts up prices of production. So it's a very important economic trade-off that we have to explore here. I thought you'd be interested as well. In this particular article, they also explored a breakdown by region. So we can look at the impacts here in Latin America. Again, the size of the bars show the relative impact on food prices. The higher the bar, the higher the food prices. And one of the interesting things I just want to point out here is one of the biggest impacts on food prices in Latin America are due to the no afforestation in boreal regions, so the high latitudes. So why should boreal regions have anything to do with the tropics? That's because if you're not afforesting in boreal regions, then it means that the reforestation has to be picked up elsewhere in tropical regions. That's competition for land, that leads to higher land prices. The important point here is that none of us is acting in isolation. There are global teleconnections in our macroeconomic world. So the decisions about land-based mitigation that are made in some parts of the world will have impacts in other parts of the world, and vice versa. So we're teleconnected globally. So what can we do to try to solve some of these conundrums? I've showed you some of the problems of land-based mitigation, but can we start to reflect on finding solutions? What can we do? Well, the obvious thing is, what can we do to make more land available for food production, for reforestation, afforestation, and for energy production? How can we make more land available? We're not going to make more land. It's a finite resource, but we can make more land available. What can we do? We can act on two sides of the equation in terms of the food system. We can look at the supply side. So if we increase crop productivity, for example, we need less land area to produce the same quantity of food. It's a simple relationship. So biotechnological development does have a place in this problem as a solution. We can also explore reducing losses. So if we don't waste or lose food, and the other one here is waste as well, if we don't lose food or waste food in our supply chains, in the distribution of food, then that means we have to produce less food in the first place. We have more land available, consequently, for other things. So trying to gain efficiencies in terms of stability of trade, transport and distribution of food, as well as the efficiency of food processing within the retail system and agri-food industries is critical in improving the efficiency of access to food by the global population. However, and critically as well, we need to reflect on the demand side of food consumption. And the two critical issues here are dietary change and how diets impact on the land area required to supply those diets, and also reduction in consumer waste. So again, if we throw less of our rather large chocolate brownies from the coffee break into the bin, okay, we're saving land. That's a direct correlation to land that's not used to produce the food that we're throwing away. So can we waste less food? Everyone. This goes to everyone, right? Okay, so these are some of the issues I want to explore. I want to give you some data and information to give you an idea of what we might be able to achieve with some of these approaches. First thing I'm just going to show you is I'm going to talk a bit about diets, because that's quite good fun. So let's first of all just look at some of the issues related to diet. What the graph, just focus on the right-hand side graph here. This shows the area required globally. This is all global data. The land area required for the supply of different agricultural goods. So what we've got here, the big blue one is Yeah, that's animal products, right? And this is through time, 1960 to 2010, short period of time, relatively, 40, 50 years. So you can see this massive increase globally in the consumption of animal products. And that can be animal products from pasture for ruminants, or it could be animal products from grain-based monogastric livestock. I won't go into some of the others, but bioenergy actually at the moment has a relatively small impact in terms of land area, but that could become greater. But the critical thing here is the livestock consumption. Globally, that's increased. Actually, globally, the world has become richer, and what tends to happen is people consume more livestock-based products. And we can see that. What this graphic shows, just focus on the left-hand side for this graphic. So this shows the period 1961 to 1994. It's a statistical analysis based on real data that shows what were the causes of consumption of livestock products during that period of time. This part of animal product consumption was due to the population increasing, okay, during that period of time. This part was due to that population changing its diet. Well, if we shift forward to the period, the following period, 1994 to 2011, what we see is the relative ratio between population growth and dietary change has shifted. So whilst population growth was critical in changing the amount of food we consume, particularly animal products, that now has become more critically focused on the diets and the types of food we consume rather than the number of population per se. So that's a critical change. That's what we've seen in the past, and that's what we expect also probably to increase in the future. Right, so here's a bit of fun. Is there anybody from the United States of America in the room? Just the one. Okay, my apologies already. But don't worry, there's a caveat. Right, what this diagram shows, what we did is an experiment. We chose 2 countries of the world, which we thought would have very different consumption habits in terms of their diets. So we chose the United States of America, which we thought might be a fairly high-consuming country in terms of calorific intake, but also in terms of livestock products, like lots of meat products. So we took the US as one extreme, and we compared it with the diet of India. So in India, there's a culture of not eating a lot of beef. There's also a strong culture of vegetarianism. So generally, meat consumption is low, and overall, it's a lower calorific consumption. So we wanted to see what would be the consequences of these 2 archetypical diets on the need to consume or use land globally. So what we did, we made a first assumption was what would happen if the whole world ate the diet of an average American, right? What would that look like? And then we said, okay, could we compare that with if the whole world ate the average diet of an average Indian person, right? And that's what this graph shows. I'll just take you through this. So look at the end. So what we have is, this is called the half index. It's the human appropriation of land for food. So it's the human appropriation of land to supply that diet. And it goes from 0% to 100% of the terrestrial surface of the planet Earth. So what we're seeing here is what this shows is if everyone in the world, the whole population of the world, ate the average US diet, we would require, I think the figure here is about 98% of the entire terrestrial surface to supply that diet to the whole population. Right, clearly that's not even feasible. So the current area of agricultural land for food is about 38%, which is that dotted line. Okay? So actually, if we didn't change the area, we'd actually need about 2.5 planet Earths to supply everyone with an American diet. The bars here, by the way, just show a breakdown in the reasons for that. So where it says quantity, that means the calorific intake. And on average, in the US, the calorific intake is more than is actually really strictly required. More about that later on, because that's another critical factor. The profile gives the type of foods that people consume, so whether it's a meat-based diet or a plant-based diet. So then, doing the same for an Indian diet, you've probably worked this out by now, you're probably ahead of me, and looked at this bar down here. So if the whole world ate the average diet of an average Indian, then we would require, okay, less than 20%. It's actually about half of the current agricultural area. We would need half of the current agricultural area to feed everyone in the world on a perfectly reasonable diet. Right? Now, that represents a lot of land saving in terms of potential for reforestation, bioenergy, et cetera, et cetera. And I'm not standing here saying that you all have to rush out and start eating chicken tikka masala, although more about the chicken later. But it does show the range of possibilities of how much land potentially we can save simply by changing diets. Even in small ways, the impacts can be significant. Right, so what we all really want to know, of course, is where does Colombia come in this assessment, in this analysis? Any ideas? Okay, I'm not just going to show you Colombia, I'm going to show you the whole world. Right, here we are. So this is exactly the same calculation. It's the half index. Okay, so again, 0 to 100. You might notice the legend actually goes above 100, which is quite interesting here. And this is all the countries of the world. It's the same assumption. So if you take Australia, this means how much land would you need for the whole world to eat an Australian diet. Okay. So the caveat, sorry for the lady from the US in the back there, the US is not the worst country in the world, if that helps at all. Actually, the worst is New Zealand. So I don't know if there's anyone from New Zealand. If you sneak quietly at the back, we'll understand. Followed by Australia. And then the next one actually is Argentina. So Argentina's right up. Very, very high beef consumption, very high meat consumption, which is the reason. And these countries actually require about 133% of the terrestrial surface of the Earth to supply those diets. Obviously, that's not going to work, is it? Colombia, where are you? Up here. Looking not too bad, but you're sort of in the 60 to 80% range. So you're still you would still require, if you on average, twice the current agricultural area to supply the diet that you eat on average. Yeah, gets tricky, doesn't it? I'm not even going to look at Europe. That's terrible as well. Right. Okay, and just to show you that these things are changing through time quite dramatically. So you've got countries like the US, the UK, that are right up there. It's unsustainable. We need to look at ourselves and reduce or change the way we consume food. But also, you know, if you look at, this is Brazil. Ignore the dotted lines, just look at the solid lines. This is Brazil, and you can see this massive increase through time in the appropriation of land for food consumption of the average Brazilian. So things are really changing, and China is coming up as well. And again, this is just reflecting shifts from plant-based to meat-based diets. Absolutely critical in understanding some of these issues. Right, I'm not going to spend a long time on this. It's the same concept as before, but it just shows you, we did another stylized experiment. We said, okay, let's look at alternative protein sources. We don't have to eat livestock to get protein. We can have other protein sources. So we did the experiment by replacing half the current livestock production with individual things. So if we did it for beef, beef is right up there, that's really bad. Pork is much better, but still not great. Chicken, poultry is getting better, but we looked at other things like insects, crickets, mealworm, things like that, which are very tasty and also staples in some parts of the world. But they're very, very good sources of protein. The difference is they have a much more efficient, insects have a much more efficient feed conversion ratio of biomass, plant-based biomass into protein. So it's a very efficient way of using land. If you want to eat protein, eat insect protein, much more effective. Actually, things like milk is not bad, and soya. Soya is really good as well, soybean. Okay. Anyway, so just to give you an idea, there's a few alternatives. You're trying to find solutions. There's a few things we can all do to do things differently. Talked about waste. This is another important issue we need to reflect on. I think some major issues here as well. What this diagram shows, it appears a bit complex, but what it's showing is the whole supply chain from the production of biomass on the left-hand side through various processing, distribution stages to the food that arrives on our plates that we actually eat. And as you can see, this is cropland here, this is dry matter, a biomass, and this is grassland. The colors show what moves through the system. The gray areas show what drops out. So it's either, it could be a residue in this case, so actually, you don't eat all of a crop, so some of it is reused, it's replowed into the soil. It's not strictly speaking a waste, it's a residue, but we don't consume it. And as we go through, there's things like crop transportation losses coming in, losses due to livestock production. That's the inefficiency of turning biomass into meat. We have processing losses here, animal distribution losses, waste by consumers, and another one I'll come on to in a moment, overconsumption. So what we have is this amount of biomass, which is produced on land, turns into this amount of food consumption and this amount of non-food consumption that actually arrives on our plates. So all along this chain, there's enormous potential to improve the efficiency of transportation, the efficiency of food processing, the efficiency of distribution and access to food, and also the efficiency of not wasting food once it arrives with the consumer. So many, many things we can do. If we could make this end bigger, then this end can be smaller, okay? That means more land available for other purposes. And this is moving up towards one or two final slides. And I mentioned on the previous one this issue of overeating, and it's actually quite shocking in a way. When we're doing this experiment, one of the headline things you see in newspapers all the time is about consumer waste. We throw food into the bin, into the trash can, and that's not good, obviously. It's a waste of food, it's a waste of land. And what we found was that of the harvested crops, about 9%, so nearly 10%, is wasted, is thrown away. Right? We don't consume it. It's good food, it's gone past its sell-by date, we don't use it. Again, so we can effectively save an enormous amount of land if we could do better at not wasting so much food. But what we found was also quite shocking was more than that quantity was wasted through overeating. So obesity and overweight is becoming increasingly a global phenomenon, not just in the developed world, in the developing world as well, and it's simply a food waste. We're over-consuming, consuming too many calories. So the statistics from The Economist show that nearly 30% of the global population are overweight or obese. That's enormous. So if we could address that 10% of waste from overeating, we could save enormous amounts of land at the consumer side. So that's a personal responsibility that all of us have on reflecting on the quantity, the type of diets that we consume, but also how much food we consume, because we all as individual citizens have a role to play in saving land for reforestation, for biodiversity, etc. Some of these figures are quite shocking. There's something like 3 times more people overweight now globally than there are malnourished people. That's not to say that malnourishment is not still a problem and still incredibly important, but we have to recognize that there is an emergent property, an emergent process, an emergent issue around the issue of overeating. Some of the data I was showing you earlier about protein consumption or livestock consumption, again, I was focusing on the top end of the overconsumption, but we have to recognize that there's also the importance of equality in diets as well. And many of the countries of the world still have a deficit in protein consumption. So many parts of the world need to actually increase their livestock consumption rather than decrease. It's the over-consumers that really need to reflect on how much they're consuming. Right, I'm going to try and wrap some of this up together in this incredibly complex diagram, which is much simpler than it looks. So I'll just take you through. I think it's my last slide. And this is a study we did in Europe. So Alma mentioned earlier that one of the responsibilities of regions of the world like Europe, who are large consumers, is not to displace our consumption to other parts of the world, leading to deforestation in other parts of the world. So we did an experiment of saying, okay, let's say Europe doesn't increase its imports of food, we keep that fixed. Could the European territory actually reforest? Could we actually store more carbon in forests in Europe? And if we could, how could we do that? So what we have in this figure, on the left-hand side, we have the forest area, okay, of Europe in million hectares. On the x-axis, we have the calorific intake, so the quantity consumed as calories. And we looked at various afforestation targets from the literature and for political processes such as the Bonn Challenge. So we tried to work out, could we achieve, what do we need to do to achieve those different afforestation targets in Europe? Now, what the symbols represent are individual model runs. So we've used a European model to look at this issue. And what we focused on is what I started with, the issue of the supply side and the issue of the demand side. The supply side in this case is about crop yields. So can we improve crop yields as we've done all over the world historically over the last 40, 50 years? We've made major gains in crop yields. Slightly contentious about whether we can continue into the future to do that, but we made some assumptions here about percentage gains in crop yield. So at the top end, this symbol represents a 75% increase in crop yields. And we also looked at a range of scenarios of meat consumption. So no meat consumption at all, everyone becomes vegetarian, reducing meat, substituting beef for other types of protein sources, or no change at all. And in a way, what the graph actually shows is quite shocking. So if Europe wants to achieve any of these reforestation targets, you look at the colors of these points on this graph. They are all blue. That means less meat or no meat. Right? And they also assume very high crop yield gains. So that's the 75 and the 60% crop yield gains. If Europe wants to maintain its current calorific consumption level. So these are quite shocking. So basically what we're saying, unless there is a profound change in the food system in Europe in terms of both crop yields and consumption patterns, there is no way that Europe can increase its forested area without displacing those problems elsewhere in the world. And any of the scenarios, or the model runs in this case, which are these blue and orange, sorry, the reddish, brown, orange colors, which are the no change in diets, that would assume very, very major reductions in total calorific increase. So there are enormous trade-offs and reflections that people within all societies of the world, particularly in regions like Europe, need to reflect on here. So this is just the final slide just to finish up with. There's insufficient land to deliver all the ecosystem services expected by a growing population. So we need to reflect on what that population does. Compromises or trade-offs are needed. That could be, for example, on changing diets, on changing wastes, gaining efficiencies. We need to focus on the supply side of sustainable land management. That's always going to be important. Reducing greenhouse gas emissions, reducing other impacts on the environment, including biodiversity, is critical. But we cannot escape the fact that consumption side, particularly diets and animal-based products, is critical in achieving major gains that will mitigate climate change. Land-based mitigation, I think as Alma's already said, is not a panacea for climate change. We need to decarbonize the economy, and we need to do that rapidly. We cannot assume that land-based mitigation will deliver us from the problems that we've caused as a global society. And particularly using large-scale bioenergy production is difficult to justify at this current moment in time, given its impacts on food security and food prices. So, it doesn't sound so positive, but thank you very much indeed for your attention.